What's up, everybody, and thanks for joining us to celebrate Cruinniú a National Day of Creativity. Could there be anything cooler?
No, there could not.
Just no. I'm Mark.
I'm Saoirse.
And you've joined us here at Explorium in our creative lab, where we get up to all sorts of experiments. Yeah.
Experiments.
There's lots of explosions too, though.
Yeah.
Many not planned, and the odd fire alarm, 1 or 2.
14.
Okay, someone's counting. Anyway, we want to share some climate demonstrations and activities with you so you can learn more about our changing climate and the impact of climate change. And we're going to show you some creative solutions that scientists, engineers, artists, technologists have come up with to protect us against the consequences of climate change. But much more importantly, to protect our planet and to make better decisions for our environment.
Our pale blue dot.
The only place in the known universe to support life. Although, do you ever meet some people and you're like, you have to be from a different planet?
I have no idea what you're talking about.
We'd also love for you to try out these demos at home or school or wherever you think is cool. And if you do, definitely let us know on social media.
We've also been inspired by World Oceans Day to create some activities about our ocean that show how important the ocean is to life on Earth and how climate change is affecting our oceans and everyone and everything that dependent on it.
And spoiler alert, all life on Earth is dependent on the ocean. And we're also joined by a few special guests who will be keeping a close eye on proceedings. Hell yeah! Alright, how's it going? Hi!
I really shouldn't be here.
So let's go! The ocean is the driving force for weather and climate. Weather refers to short-term atmospheric conditions. Look out the window. That's weather. It's probably raining.
It is raining.
Weather's different in different parts of the world and changes over minutes, hours, days and weeks.
Climate describes what weather is like over a long period of time in a specific area. Weather tells you if you need to wear a raincoat today. The climate tells you whether you need to rethink your entire wardrobe.
I probably need to rethink my entire wardrobe anyway, irrespective of climate. I've seen your type before. Flashy, making a scene. Ah, you look lovely. Thanks. Climate change refers to long-term changes in the Earth's weather patterns or average temperature. Interactions between the atmosphere, oceans, ice sheets, land masses and vegetation create a climate system.
Changes in climate can arise naturally due to the cycle in the Earth's orbit, but since the mid-19th century, a rise has occurred in the average global temperature, and the rate of change cannot be explained by natural causes alone.
Human activity, including burning of fossil fuels and then the increase in greenhouse gases, is changing the Earth's climate, with consequences that affect all life on Earth. Me, you, them.
Carbon dioxide is one of these greenhouse gases that traps the sun's heat on the Earth, warming the planet.
Climate change will mean altered weather patterns across the globe, with different parts of the planet affected in different ways. There'll be changes in rainfall patterns, increased desertification, melting of glaciers and ice caps, sea level rise, and increased likelihood of severe weather events.
The ocean and the climate are closely linked. The ocean plays a crucial role in the global climate system in a number of ways. These include absorbing excess heat from the atmosphere, regulating our temperatures, almost acting like the Earth air conditioning system, warming in the winter and cooling in the summer.
Ooh, lovely.
Yeah.
But ocean heat is at record levels. The ocean also absorbs around 30% of the carbon dioxide added to the atmosphere by human activity and helps mitigate the impacts of climate change. Absorbing additional CO2 is increasing the acidity of seawater. This process is known as ocean acidification. Saoirse, let's take a closer look at it.
Let's go.
To show the effects of excess CO2 on ocean acidification, we're going to use a pH indicator.
But at home, you can also use cabbage water.
Yes.
You make this by chopping up the cabbage, you put it in a pot of water, you boil it, and then you strain it.
Sounds like a lovely evening.
Yes, very smelly.
Yes. If you're looking for a lovely smelly evening, no better activity than boiling red cabbage water. And then you just strain it off into the bottle?
Strain it off into the bottle, and it changes colour depending on the pH level of whatever you put in.
Oh, awesome. So same as this, different scales though. You can
Yeah.
look up the colour change scale online for this. You'll see this one in a moment.
Yeah.
And after you've made your red cabbage water, you just carry it everywhere with you like you've done.
Yes.
Ocean acidification is the decrease of the ocean's pH level. The pH scale is a measure of how acidic or alkaline a substance is.
An example of an acidic substance would be vinegar. An example of an alkaline substance would be baking soda or bleach.
Okay, and the scale ranges from 0 to 14, with 0 being highly acidic, 7 being neutral, and 10 to 14 being alkaline. So let's show how it works. We have got 3 glasses of water here, which we have put some pH indicator into, and that has told us the pH value of the liquid, but we've added different liquids to the water in some of them, different substances. This one is just water. So we put some drops of the pH indicator inside, and it's turned a blue, a very light blue, which on the pH scale tells us it's slightly alkaline, which is perfect for safe drinking water.
Perfect.
And what have you done to your one?
I put a bit of vinegar in my one, and you can see it's kind of yellow, which means it was over here on the acidic side of the scale.
I've put bleach into this one, and we know that bleach is alkaline, and it has turned ours a nice shade of purple.
Yeah.
I think so. So that is, on the scale, alkaline. Okay, so we want to see what will happen if I put excess CO2 into our water and see what color change it'll cause with our pH indicator. Now we just need to get CO2 from somewhere. Where can we get it?
Take a big breath of
Take
air.
a big breath of air. We breathe out CO2. So I'll use the CO2 from my lungs to see if it'll change the pH value of the water. And for that, I will need a straw and a big breath of air.
This behind it? So
Yes, we can see the change. Okay, okay.
Perfect.
Okay, very quick, and I've spilt a lot of it. But we can see that it's changed to a lightish yellow.
Light yellow. It's going yellow, yeah. But it's definitely not blue anymore, so it has changed.
So it has changed. And on the scale, that tells us that I have made this water more acidic from the carbon dioxide in my lungs.
Yeah.
Human activities and the burning of fossil fuels are releasing too much carbon dioxide into the air, which is increasing the level of CO2 in our ocean. Saoirse, let's scale this up.
Do it.
This will be our ocean. Let's do one each. Let's add some pH indicator. The color scale tells us it's slightly alkaline. We're going to take a deep breath in and blow through the straw into the water to see what effect the CO2 in our lungs has on the pH value of the water. Do you think it'll get more alkaline or more acidic? Ready?
Yep.
Okay, let's go. It turned yellow, which tells us it became more acidic. Okay, so it's turned into a yellowishy green kind of colour.
Yeah.
Showing us on the scale it was definitely more acidic.
Definitely
Now,
more.
you could also try this with your red cabbage indicator.
Yeah.
It would turn different colour depending on the scale for a red cabbage indicator, but you can find that online.
Yeah.
Ocean acidification has dramatic consequences for marine life. If seawater is too acidic, it can make it difficult for marine organisms such as coral, oysters, and mussels to form shells and skeletons.
We can help prevent ocean acidification by reducing your CO2 emissions. Having less CO2 in the air means less dissolved CO2 in the sea.
Carbon capture and storage is a technology that captures carbon dioxide and prevents it from entering the atmosphere and contributing to climate change. The captured CO2 is conditioned, compressed, and transported for permanent storage deep underground. Pretty cool.
Yeah. MIT engineers are also developing a new way to remove carbon dioxide from the air. Their device is essentially a large specialized battery that absorbs the carbon dioxide from the air. This traps the carbon dioxide and can be used and repurposed so we don't burn fossil fuel.
Ah, cool. The ocean is essential for life on Earth. Without it, our planet would be uninhabitable for humans, animals, and planets. The ocean covers 70% of the planet's surface, and 97% of the Earth's water is found in the ocean. So it also plays a huge role in the water cycle. Saoirse, why don't I show everyone how to make a water cycle in a bottle, and you can get ready for the next activity.
Oh, cool. I'll go get the sea and get some salt water. I'll go to the sea.
Get the
and
whole
I'll
sea.
go to the sea.
We definitely need some salt water.
Yes.
Yes, okay. See you soon. Oh, she didn't like that. Let's make a water cycle in a bottle. Where does rain come from? And how does water get into the clouds? You will need a plastic bottle with a lid, about 200 ml of water, a drinking glass, some food colouring, some ice cubes, don't ask, and a marker. Pour 200 ml of water into your bottle and add some food colouring. Then put the lid on and mark the level of water. Turn the bottle upside down, place it into your glass. Observe where the water is in the bottle. Now place some ice cubes on top of the bottle and place it in a sunny location. Turn the bottle upright and observe the water level. What happened to the water inside the bottle? The water cycle starts when energy from the sun causes liquid water on the surface to turn into a gas called water vapor. This process is called evaporation. The water vapor rises into the sky, and as it cools down, it turns back into liquid water to make clouds. And this process is called condensation. Eventually, the liquid water will fall back down as rain, sleet, or snow. And this is called precipitation. Then, the process begins all over again, and that's why it's called the water cycle. And yes, that means all our water is not new water, but it's actually been used millions of times before. Without water, there'd be no life on Earth. Inside our bottle, water evaporates, turning from a liquid into a gas, and rises into the air in the bottle, and rises to the top. The gas water vapor cools down when it gets to the top of the bottle, where the ice is, and condenses back into a liquid. This is where our clouds form. You can see the condensation on the top. Eventually, the liquid drops fall back to the bottom of the bottle. Then the water cycle starts all over again. Evaporation, condensation, precipitation.
I'm back.
Hello.
Hello.
You got the sea salt water from the sea?
Salty sea water from the sea. It was very difficult to cycle up on my bike with it.
You brought a bowl.
I didn't have a bottle.
Cycling?
Yes.
Oh, well, okay. I've showed everyone how to make a water cycle in a bottle, and it kind of got sunny for a little bit too.
Oh, nice.
Which was really, really nice.
Cool.
The ocean helps us in many, many ways. Ocean currents move warm and cold water around our planet, which helps regulate the temperature of the planet and helps transport nutrients and marine life around too. So let's investigate how ocean currents form. You'll need 2 small jars. You can use ones like this, but we're going to use big ones like this.
You'll also need some food colouring, some water, some salt if you couldn't make it to the sea, and a spoon.
Ooh, and some thick card or plastic that is larger than the openings of the jars. And then you'll also need a spill tray for possible likely spillages.
And a towel for cleanup.
Ah, cool! First, let's investigate the effect of temperature on water density. Fill 1 jar to the top with cold water and add some blue food colouring. This is our cold ocean water, like that at the polar ice caps. Fill the other jar with warm water and add some red food colouring. This is our warm water, like that at the equator. Place the card on top of the warm water and then turn the jar upside down and place it on top of the cold water. So we have the warm water on the top and the cold water on the bottom. What do we think will happen when I remove the card? Nothing happens. That looks cool, doesn't it? The cold water stays on the bottom and the warm water stays on the top. This time, let's try it again, but let's place the warm water on the bottom and the cold water on the top. What do you think will happen this time? The warm water starts rising upwards. As water is heated, it expands and becomes less dense. Things that are less dense float on things that are more dense. The warm water rises very quickly and the cold water sinks, and as they do that, the food colouring mixes.
In our oceans, warm water at the equator rises and travels towards the poles, where it gets cold and more dense and sinks to the bottom. The sinking cold water travels along the bottom towards the equator, where it warms up and rises again. This circular motion is called thermohaline circulation.
Thermo meaning heat and haline meaning salinity, which is how salty the water is. So we've just seen how the temperature affects density. So let's discover how the salinity affects the density of water. This time, fill 1 jar with salty water, and you can do this by adding salt to your water. Fill the other with fresh water from the tap.
You'll also need some food colouring.
And your card again. Let's dye our salt water green and label it too. And let's dye our fresh water yellow so we can track their movements. Place the card on top of the salt water jar and put it on top of the fresh water. What will happen when I remove the card?
Let's see.
Wow! The salt water sinks to the bottom and the fresh water rises to the top. Salt water is more dense than fresh water, so it sinks. Fresh water is less dense than salt water, so it rises to the top. And as we've seen, things that are less dense float on things that are more dense.
In our oceans, as water moves towards the poles, it gets colder. It also gets saltier because when sea ice forms, only the water freezes and the salt gets left behind in the surrounding water, making it saltier. As we've seen, salty water is denser and sinks.
So we have cold, salty water at the poles sinking because it's more dense, and warm water rising at the equator because it's less dense. And the movement of these currents form a circular motion, thermohaline circulation, heat and salt. That was absolutely awesome. Very
cool.
funky and psychedelic as
Yeah,
well, wasn't it?
very
Really
visual,
cool.
yeah, really
Very
nice.
visual, seeing how those ocean currents can form. We did it in a big jar, a big fish tank like that, but you don't have to pop your fish anywhere else. You can do it with much smaller containers as well. We just did it on a supersized scale. So you can get a very small container and try it out for yourself. Bit of ice, bit of food colouring, and do it. Because we want everyone to get creative. You don't have to copy exactly how we did it. We want you to come up with your own methods.
Yeah, use your own cool funky jar.
Exactly, yeah. We want you to use your creativity and your imagination to maybe do some different things than we did. Use different colours. Go crazy. It is up to you. It's the National Day of Creativity.
Creativity, different
We
colours.
want you to unleash your imagination. And again, if you come up with something awesome, something new, we'd love to see it. So you can share on social media and share your knowledge with the world, because that's how science works.
Sharing,
Yes,
researching, learning, telling everyone about it.
Nobody works alone. It's best to work in teams and collaborate, and that's where the best ideas come from as well. You have ideas, I have ideas, we combine our ideas, mega
more
ideas.
ideas.
So many ideas. Guys, thank you all so much for joining us in our lab. Not many explosions, which is good.
No,
Yeah.
No fire alarm?
Imagine it was. We hope you do try out some of the activities and demonstrations and do them wherever you are. Again, use the activities and materials that we use or come up with your own as well.
And making a big mess is very creative. Big mess.
The parents are like, don't say that. She didn't mean it, I swear. She didn't mean it, okay? But we want you guys to get creative and expand your mind, because scientists work with engineers, work with technologists, work with artists to come up with these creative solutions to the problems that we face. And none more important than the challenge of climate change, which requires, as we've seen, lots of really creative solutions from all types of people, from all types of backgrounds,
all around the world,
working together to come up with creative solutions. And we know that you guys watching as well will be our saviors of the future and will create technologies that will get us out of this mess. So we hope we've inspired you. And there's many other things you can do as well to protect your environment as well. So many things. We've seen a lot of the technologies as well. So using renewable energy is really, really important.
Instead of fossil fuels, because fossil fuels are very bad for the planet, because they're, first of all, they're running out. It takes millions of years to make them, and we don't have very many left. But they're also emitting so many greenhouse gases like carbon dioxide into the planet, causing global warming, climate change, ocean acidification, all of them, everything.
So we can focus more on renewable energies
Yeah.
like solar power, wind
power.
power, wave power.
Oh, yeah, all
There's
of them.
many of them. Wind power. So creating lots of different ways to produce energy that's renewable as well. So we're not relying on burning fossil fuels.
An example of creativity as well, a problem that was faced with them was storing them, because solar energy only happens during the day.
Yes, in some countries.
Not here. We don't use solar energy here. But storing the energy was a really big problem. But scientists, technologists, engineers, everyone has already created some solutions like hydro pump electricity, all of these things to help store those bits of energy.
Very cool and really, really innovative type
Very
new
clever,
things.
yeah.
Ways to think differently, because the only way we can advance is to think differently than we have done before.
Exactly.
Using your tools of your wild imagination and creativity and working together crazy in a team. And there's also many things, of course, reducing, reusing and recycling.
Oh, yeah.
We try to do that as much and wherever we can. You can walk, bike or take public transport where possible.
You can turn off the tap when you brush your teeth.
I did that once. You never let that go. I did it once.
How much water was wasted?
Once. I'll never do it again.
Okay.
He never lets that go. You can shop sustainably.
Yep.
That's very important. Make sure you're getting using sustainable things, shopping sustainable, using sustainable foods that are being formed and got in sustainable practices.
Yep, and unplug everything when you're not using it. All the electronic devices in your kitchen, in your living room, unplug them if they're not on. You don't need them on.
And the greatest tool you can equip yourselves is knowledge, and then apply that knowledge.
Yes.
So you can learn more about your carbon footprint. And we hope to encourage you to do that. Find out as much as you can about the impact you're having on the environment and what you can do to help protect it. Now, we have been joined by some very lovely guests, and thank you all for joining us. We hope you enjoyed it too. Deadly, nice, class, good luck, you know. Ah! And we hope you've also enjoyed it. So we want you to unleash your creativity and your imagination. And thank you for joining Mark.
And Saoirse.